Black holes are perhaps the most fascinating structures in our universe. While we have some good knowledge about how they form and what surrounds them, we still have absolutely no idea what's inside them or what really happens there. We don't know what would happen to a person or a probe falling into one. But there's something that might be even more mysterious than black holes. Something that might not even exist. White holes. White holes are defined as the exact opposite of black holes. Instead of pulling everything inward, they push everything away. The existence of white holes is still debated among scientists, but everything about this idea began with Einstein's theory of general relativity. Formulated in 1915, this theory explained how the fabric of the universe, space and time, is curved by mass. And in our next video, we'll dive into the relationship between space and time itself, so don't forget to stay tuned for that. Anyway, as a result of Einstein's equations, a solution known as the Schwarzschild metric became famous over time. This solution described a black hole. But when you reverse the equations, when you turn time backward, it also reveals that a structure called a white hole is mathematically possible. So, theoretically speaking, if black holes are cosmic vacuum cleaners that operate forward in time, white holes are cosmic fountains that operate backward in time. While a black hole swallows matter from the universe, a white hole spits it back out. However, over the years, some scientists began to suspect that black holes and white holes might actually be two sides of the same coin. That is, a black hole could be the entrance of a cosmic tunnel, while a white hole could be the exit. And from this point on, things started to get really interesting. This is where the explosive theories and myths about white holes began. The most famous of these theories is the Einstein-Rosen bridge, better known as the wormhole theory. According to this idea, a black hole acts as the entrance to a wormhole, and a white hole serves as the exit. The logic is that if matter gets pulled into a black hole, it could be expelled somewhere else in the universe through a white hole. If we could ever gather enough data and find equations to determine where the expelled matter might appear, black holes and white holes could revolutionize space travel, allowing us to cross unimaginable distances almost instantly. But when this idea first appeared, scientists faced one big problem. No one knew how a white hole could actually form. We already know that a black hole forms when a massive star runs out of fuel, collapses under its own gravity, and reaches a point of infinite density, a singularity. But for white holes, we have absolutely no idea about such a process. Even more interesting, we have no observational evidence of any natural structure in the universe that spews matter outward instead of pulling it in. For decades, humanity has observed the universe, explored planets, galaxies, and moons, and even captured the first image of a black hole, but we have never found even the slightest trace of a white hole or anything resembling one. At this point, some began to think Einstein might have been wrong, that white holes simply cannot exist. In contrast, others argue that white holes may have formed at the very beginning of the universe. According to this theory, white holes emerged right alongside the gases, dust, and matter that were born during the Big Bang itself. In fact, this idea suggests that our entire universe could be a white hole. If you think about it, the Big Bang describes a point of infinite density that suddenly released enormous amounts of energy and matter outward, exactly what a white hole is defined to do. If that's true, then every black hole might be the birthplace of a new universe. In other words, our universe might have been born inside a black hole of another universe. This would mean that every black hole gives birth to a new universe, and each universe creates its own white hole, a never-ending cosmic cycle. If this theory is correct, then studying the earliest moments of our universe could actually give us a glimpse of what existed before our universe. Imagine, maybe 200 or 300 years from now, scientists will be able to confirm this theory and witness the birth of new universes by studying black holes. Perhaps one day, with enough technology, we might even observe the very black hole that gave birth to our universe. Space gives us these strange and beautiful mysteries. It truly is a fascinating place. Now let's talk about the role of quantum physics in all this. The theory that every black hole gives birth to a universe and every universe creates its own white hole actually finds some support in quantum physics. That's because classical general relativity alone cannot explain what happens inside a black hole. Einstein's equations lead to a singularity, a point where all the laws of physics break down and everything we know becomes meaningless. But quantum mechanics tells us that nothing can truly become infinite. To resolve this contradiction, a concept called loop quantum gravity proposes something fascinating. Black holes collapse only up to a certain point, and then they bounce back. Instead of collapsing forever, they expand again due to quantum effects and eject all the matter they had consumed. This entire process is known as the transition of a black hole into a white hole. So the idea that black holes and white holes are two ends of the same tunnel might not be entirely true. Instead, white holes could actually be the final stage of black holes. According to this theory, black holes aren't immortal. Over time, they lose their energy, shrink, and finally end their lives in a burst known as a white hole explosion. It's quite similar to how a star evolves into a white dwarf or collapses into a black hole. This explosion could also release intense radiation into space, possibly explaining the mysterious gamma-ray bursts we sometimes detect. Some astrophysicists even suggest that these short but powerful bursts of energy could be the final breaths of dying black holes. And of course, Stephen Hawking made equally groundbreaking contributions to this topic. In 1974, Hawking showed that black holes aren't completely black. They slowly evaporate by emitting energy in a process now known as Hawking radiation. If this process lasts long enough, billions of years, a black hole could completely evaporate, leaving behind a small, unstable bubble of energy. And perhaps, just perhaps, that bubble could transform into a tiny, short-lived white hole. If you're wondering whether we have any observational evidence for white holes, the answer is, well, not exactly, but there are some intriguing indirect clues. Some astronomers believe that sudden bursts of energy observed in intergalactic space, especially those known as fast radio bursts, might be linked to white holes. These signals last only a few milliseconds, yet they release as much energy as a star emits over millions of years. Scientists have struggled to explain how such an enormous amount of energy can be released in such a short period of time. So instead of turning to theories about alien civilizations or other far-fetched ideas, some researchers have started focusing their attention on white holes. Because if white holes truly exist, their ejection of matter could produce exactly this kind of massive energy burst. Of course, this remains purely hypothetical, but honestly, there doesn't seem to be a more reasonable explanation for these mysterious phenomena. Still, theories about white holes certainly don't end there. Let's go through the main ones, and I'll tell you which I find most convincing. The first theory stems from Einstein's general relativity equations, which actually allow for the existence of a universe where time runs in reverse. According to this idea, white holes operate as the exact opposite of black holes. Everything that falls into a black hole would be expelled out of a white hole, moving backward in time. It may sound like pure science fiction, but mathematically Einstein's equations do permit such behavior. The next major idea comes from Hawking's theory, which I've discussed before, and personally I think it's one of the most logical among all of these. But then things start to get even stranger with the theory of mini white holes. Don't let the name fool you. They're not just small versions of the massive cosmic monsters we imagine. If a typical black hole is the size of a star, these white holes would be more like the size of an atom. According to this idea, at the tiniest scale of space-time, the Planck scale, the universe is constantly creating and destroying mini black holes and mini white holes. These processes behave like quantum energy fluctuations, appearing and vanishing almost instantly, which makes them nearly impossible to detect. Still, this theory offers an interesting explanation for some of the strange, short-lived bursts of gamma rays and other mysterious high-energy events we've observed in deep space. It even accounts for why we haven't been able to see them directly. Personally, I think it's a wild concept, but one that does answer a lot of the big questions. Now let's move on to the final two, the cosmic balance theory and the parallel universe theory. The balance theory suggests that if black holes exist, then white holes must also exist, because the universe always seeks equilibrium. Black holes constantly consume matter, swallowing up enormous amounts of it across billions of years. For the cosmos to remain stable, there must be something to counterbalance this process, something that gives matter back. And that, according to this idea, is the role of white holes. While black holes devour, white holes release, maintaining the grand balance of the universe. Finally, we have the parallel universe theory. You've probably heard of this one before. Black holes serve as entrances, and white holes as exits to tunnels connecting entirely different universes. Together, they form what we call a wormhole. Personally, though, I find this theory the least convincing, because if white holes can be mathematically plausible, parallel universes should also leave some kind of trace. But so far, we haven't found a single piece of evidence for their existence. Einstein's equations allow for white holes, but no existing framework truly supports the reality of parallel universes. In the end, even though white holes have never been observed directly, many scientists still consider their existence theoretically possible. They remain one of the universe's most mysterious and fascinating ideas. We might not fully understand them yet, but I'm certain they hold secrets that could completely change the way we see reality itself. The universe continues to surprise us, again and again, with its strange beauty and endless complexity. I truly hope one day we'll have the chance to explore it up close, to witness these cosmic mysteries firsthand. That's all from me for today's video. If you enjoyed it, don't forget to subscribe, leave a like, and share your thoughts or new video ideas down in the comments. It really helps the channel grow. Thank you so much for watching. Take care of yourselves, stay curious, and see you in the next one.